kcse Vision channel, Marita James, People's Process School. Kindly subscribe, click the notification bell, you get notified once I upload a new video. Today we are looking at Form 4 work, the extraction of metal, and we are looking at the extraction of the aluminium metal. In the extraction of a metal, the main thing first that a learner is supposed to know is the ore where the metal is being extracted from. So for instance here that we have the ore from where aluminium metal is being extracted from. The ore, first ore we have as the dioxide, which is a formula of aluminium oxide, and of course which is a formula of hydrated aluminium oxide. As you can see, this one here, it contains some water molecules. And then we have another ore which is called the corundum, where we have, which is a compound of aluminium oxide. We have also have a mica, a compound of potassium, aluminium, silicon, and oxygen. So the chief ore, the main ore from where aluminium is extracted from, aluminium is normally extracted from the dioxide. So this one here, this is the chief ore. So we have this as the chief ore. So the chief ore where aluminium is extracted from is normally dioxide. So sometimes the learner will be asked to name the ore or also to write the formula. So the name of the ore is just dioxide and the formula is just this one here. Now, during the extraction of the metals from underground, the metals normally, the ore normally contains some impurities. Now, what are the impurities that is found in this ore of aluminium oxide? So we have impurities in the ore. One, we have iron 3 oxide, and then we have the silicon, which is silicon 4 oxide. These are the major impurities in the ore. So we have as aluminium oxide, and then we have the silicon. Silicon is normally the silicon oxide. Now, how is these impurities are being removed? So, how do you remove these impurities? That is the iron trioxide and the silicon or the silicon oxide. First, you can have the crushed ore is dissolved in a concentrated sodium hydroxide, whereby aluminium oxide is an amphoteric compound, whereby now it will dissolve the base, and silicon oxide is also an acidic compound. It can also dissolve in a concentrated sodium hydroxide. Therefore, aluminium oxide can dissolve in concentrated sodium oxide, and the silicon oxide can also dissolve in aluminium oxide. The iron 3 oxide is also insoluble and therefore is filtered out in the process. Now it is being separated. So the crushed ore is dissolved in a concentrated sodium hydroxide, whereby aluminium oxide and the silicon oxide can dissolve in the base. Then we have the iron 3 oxide, which is insoluble, is filtered or separated out. So that is how the impurities are being removed. In this process, you can see on this diagram, the process of a method of extracting this aluminium is extracted by a process of electrolysis. The process is electrolysis in the method of the Hall's cell. So this cell here, the cell you can see is called the Hall's cell, and the process of extraction of this aluminium is through the process of electrolysis, because aluminium is a reactive metal. Those reactive metals are extracted by the use of electrolysis. In these Hall cells, the aluminium oxide has a high melting point of around 2000. So the process of electrolysis will not be carried out at this very high temperature. It is very economical and it is very expensive. So what is being done to lower this melting point or to make the process more economical? This compound of the ore is dissolved in a molten cryolite, which is also added. The molten cryolite is added in the ore to lower the melting point from 2000 to around 1000 to 2000, from 2000 to around 1000, which is more economical, where the process of electrolysis can take place. The molten cryolite, it has two purposes, it has two functions, whereby one, it can lower the melting point. It lowers the melting point normally from around 2000, so it can lower it from around 2000 to 1000 to make it more economical for the process of electrolysis to take place. And also, this cryolite, it can also improve the electrical conductivity. So those are the two main purposes of this cryolite in these whole cells. It lowers the melting point to make the process more economical and improves the electrical conductivity. Now, as you can look at this diagram, we have the graphite, and the graphite which is used as the anode. The graphite is used as the anode because why is the graphite being preferred? Why do we prefer using this graphite as the anode? So, reasons why we prefer graphite is because they are inert. You can have this, they are inert. Inert means that they do not react, they do not combine with the chlorine, they do not combine with oxygen, so that's why now they are inert, they do not react. That's why it is being preferred. Another reason graphite is also preferred because they are cheap, readily available, they can be obtained, and also they have a high melting point. So the three reasons why the graphite anode is being preferred: they are inert, they are cheap, and therefore they have a high melting point. Now, before I come here, you can, when you look at in this whole cells, in this cell, we have a molten aluminium which is tapped at the top, and the reason why it is called tapped at the top, we have a molten aluminium, and then we have a molten aluminium oxide and cryolite. As you can see, the molten aluminium oxide and cryolite is at the top. It floats on the top of the molten aluminium, meaning that the molten aluminium it is more denser. The molten aluminium it is more denser than a mixture of a molten aluminum oxide and a cryolite, and that's why it is tapped at the lower part. So it is tapped at the lower part because it has a low density compared to that of a mixture of aluminum oxide and a cryolite. Again, we can also have the graphite anode, where we have the anode. During the process of electrolysis, the aluminum oxide it is melted first for the process of electrolysis to take place. Once it's being melted, it can decompose into the aluminum ions, and then we have the oxide ions. The aluminum ions which are being positive migrate to the cathode. They can migrate to the cathode, whereby now the aluminum ions are being discharged at the cathode to have the aluminum in a liquid form, which is denser than the molten aluminum oxide. And then we can also have the oxide ions are normally negative, it migrates at the anode. So at the anode, the oxygen gas is being produced here. And since we said that this graphite is normally carbon, and therefore at this anode the oxygen gas is produced. So what will happen here is that the oxygen gas which is produced here, it normally combines with this graphite which is carbon to form the carbon dioxide, and therefore it corrodes the anode, and this makes the anode to be replaced from time to time. So sometimes you will be required to explain why the anode are replaced from time to time. The reason is the oxygen which is being produced here combines with this graphite carbon to form the carbon dioxide which corrodes the anode, and that's why they are being replaced from time to time. Then we have aluminium is heated first to melt it. So maybe you will be required to give a reason why the aluminium is heated first. Explain why aluminium is heated first before the process of electrolysis. Aluminium is heated first before the process of electrolysis to melt this one here. To melt because the process of electrolysis will not take place it will not take place in aluminum oxide. It must have melted first to decompose such that we can have the oxide ions and the aluminum ions where the process of electrolysis can take place. I said that this graphite can be replaced from time to time, because oxygen produced at the anode, they react with the graphite anode at that very high temperature. they produce the carbon dioxide gas, which corrodes the anode, which wears away the anode, and therefore they are replaced from time. They are replaced from time to time. Then we can also have that what are now the alloys of this aluminium? What are the alloys of aluminium? Aluminium normally has one major alloy, that is a duralumin. Duralumin is an alloy of aluminium which is used to make aircraft parts. And why is it? What are some of the properties that makes this duralumin to be used to making the aircraft fast? One, it is light because of its lightness, and therefore it does not corrode easily in the atmosphere. Now we can also come to the uses of aluminium. Aluminium is used to make mirrors. Aluminium can also be used to make paint when powdered. Can also be used to make paint. If you follow to my other channel, we explained why the aluminium paint is used to prevent rusting. The aluminium is used to prevent aluminium paint is used to prevent rusting because it keeps out air and moisture. So one of the uses of this aluminium is used to make paint when it is powdered. Aluminium can also used to make the overhead electrical cables because it is a good conductor of electricity and therefore it does not corrode easily. Some students can make a mistake, giving a reason why the aluminium is used to make the overhead cables. Some say that they are used to make the overhead cables because it is a good conductor of heat and electricity. That one is wrong because you cannot introduce heat there. The reason why the aluminium is used in making the electrical cables is because it is a good conductor of electricity and therefore it does not corrode easily. So simply that's a simple summary of the extraction of aluminium. You follow my channel. Next I will be uploading the extraction of lead. Kindly follow my channel. Click the notification bell. You get notified once I upload a new video. Thank you.